and today I am going to start with commutative law. So P disjunction Q has logical equivalence with Q disjunction P, and P conjunction Q has logical equivalence with Q conjunction P. So this is the commutative law. Now the distributive law. So P conjunction Q disjunction R has logical equivalence with P conjunction Q disjunction P conjunction R, and P disjunction Q conjunction R has logical equivalence to P disjunction Q conjunction P disjunction R. So this is the distributive law. Now it's De Morgan's law. Negation of P disjunction Q has logical equivalence with negation of P conjunction negation of Q, and negation of P conjunction to Q has logical equivalence with negation of P disjunction negation of Q. So this is basically the De Morgan's law. And now this is absorption law. P disjunction to P conjunction Q has logical equivalence with P, and P conjunction P disjunction Q has logical equivalence with P. This is called absorption law, as the whole things get absorbed to P. So this is absorption law. Now contrapositive. So P implication Q has logical equivalence with negation of Q implies negation of P. This is contrapositive law. And now this is negation of P has logical equivalence with P. And now this is complement laws. Like P disjunction to negation of P has logical equivalence to a tautology, and P conjunction to negation of P has logical equivalence with contradiction. So this is called the complement laws. And now negation of a tautology has logical equivalence with a contradiction, and negation of a contradiction has logical equivalence with a tautology. P disjunction with any contradiction has logical equivalence with P. P conjunction to any tautology has logical equivalence with the tautology Y. P conjunction any tautology has logical equivalence with P, and P conjunction to any contradiction and it has logical equivalence with the contradiction. So this is called identity laws. So these four laws are called identity laws. And now we will simplify a compound proposition using those laws, algebraic laws of connectives. So let me take you to the example. So let us simplify a compound proposition using above laws. So this is the proposition P conjunction to Q disjunction with negation of P. So this has logical equivalence with negation of P disjunction to P conjunction Q, and this is using commutative law. And after this, we will further simplify this statement to this one, negation of P disjunction P conjunction negation of P disjunction Q. So this is using distributive law. And after this, we'll further simplify the statement to P disjunction negation of P conjunction to negation of P disjunction Q using commutative property. Then this will be simplified into tautology. This one and this part, tautology conjunction with negation of P disjunction Q. So this is using complement law. And negation of P disjunction Q to conjunction with tautology using commutative law, and negation of P disjunction Q. So now the compound proposition has been simplified into this. So we can see how a compound proposition has been simplified into this proposition by using those algebraic laws of connectives. So here we can say that we can simplify any compound proposition into its simplest form using those algebraic laws of connectives. So today I have discussed all those laws with its example, and on the next part I will discuss normal forms, conjunctive normal forms and disjunctive normal forms. So till then, subscribe this channel, and if you have any queries related to these lectures, please write us on my comment section, and don't forget to subscribe this channel for more updates and more lectures, and also press the bell icon to always get updated.